morning, distinguished guests, presenters, and attendees in this conference. And thanks so much to KMICE for inviting me to present at this prestigious conference and talk about this important topic of big data to knowledge discovery, a difficult journey. Now, big data means many things to different people. For some people, it refers to the collection of data. For others, it refers to the normalization of the data, taking that data and making sure that it's clean data. For others, it refers to the tools necessary to analyze the data. And still others are interested in the visualization, how to present the data. But regardless of how you think about big data, the fundamental fact of big data is that big data has no intrinsic value. The value of big data comes from the ability to use it to make decisions or take actions that previously you could not have, or made so with incomplete or incorrect data. And it's this topic which I'd like to talk about today, taking big data and converting it to knowledge, changing it into something valuable to help decision makers to make better decisions and drive their businesses or drive their organizations. So my plan is to spend about 45 minutes or so talking, and then I want to open it up for questions. So what I'd like to first talk about is, what is big data? A very popular question. Who's interested in big data? Well, the bottom line is everyone's interested in big data, but I'll talk about some of the large government and intergovernmental efforts in big data. I'll give 3 specific case studies about big data, and then I want to focus on what are the challenges of big data and how we as organizations, as individuals, as universities, how can we take that big data and help turn it into big knowledge? So with that, let me begin by looking at some definitions for big data. So looking at this first definition, what do we learn about big data? Well, we learn that big data is extremely big, and it helps understand human behavior and human interactions. Okay, it's a fair definition. What about this second definition? Once again, we learned big data is big, and it helps us, and it deals with structured, unstructured, and semi-structured data. Now this is important because, as we well know, 80% of the data out there is unstructured. So again, we're talking about big data. The next definition, we learned that data comes from traditional and non-traditional sources. And again, it's big. And finally, we have a definition that really says big data is a buzzword. Big data just refers to data that's so big that you can't use traditional approaches, traditional frameworks to help understand it. So what we learned from this, aside from big data being big and some of the parts of big data, we learned that big data is, again, a derivative. It's only useful when it relates to human interaction, when it's able to be mined, when we can analyze it. So let's not use a definition. Perhaps it's statistics that will give us a true sense of what big data is. I like this first statement because it says by 2020, 1.7 megabytes of information will be created for every person on Earth. By 2020, there'll be 7.5 billion people on Earth. That means every second, 12.7 billion megabytes of information will be created. Or put another way, in the time it took me to talk about this bullet, about 150 billion megabytes of data will be created. Next, this quote made quite a stir in a number of years ago when Eric Schmidt, the CEO of Google, stood before a congressional committee and said that more data has been created in the past 2 years than at any point in the entire history of humankind. Now, I'm sure that the Google analysts can explain how they figured this out, but the important point is It just shows the exponential growth of data, and data is only going to grow more over time. Perhaps another way to think about data is look at some of the applications, video that's uploaded, emails that are sent. Again, you're talking ridiculously large amounts of data that are indeed difficult for us to comprehend. But there's one data point that I find extremely interesting in looking at big data. And it's this point here now. Of all the data out there, less than 1% of it is mined. Less than 1% of it is used and analyzed. Now, the skeptic out there will say, well, that's because 99% of it is useless. Well, that may be the case, but looking at the data, just imagine if we used 2%, 3%, 10% of the data out there to help drive our decisions, to help drive our actions. Now, when I think about big data, I like to think about it along its dimensions. And perhaps you've heard of are familiar with the 5 V's. And that's how I think about big data. The volume of big data. You know, not too long ago, I remember the days of 20 megabyte drives. Then we went to gigabytes, petabytes, exabytes, zettabytes, yottabytes, zenottabytes. So zenottabytes are 1 with 30 zeros after it. You know, we're inventing words just to describe how big the data is out there, to give you some sense of the volume. The second V, velocity of data. You know, you will talk to financial analysts, and they will tell you that shaving milliseconds off a trade translates into millions of dollars a year. And they are fighting, currently the financial institutions are fighting to shave 1, 2, 3 milliseconds off the time it takes for them to do trades. Big data is a huge issue in the financial services industry. The ability to understand the big data, write algorithms to trade is a huge business. And the ability to do it quicker and quicker translates into millions and then likely billions of dollars. The third V, variety. You know, I was working this morning in the hotel room, and I went to save a document in Word. And I typed in the name, and then it asked me what extension, doc, docm, doct, docx. 17 different potential formats to save in. Now think about that. That's just a Word document. Think about all the ones for video, for audio, and you begin to understand the variety of the big data out there and how it's stored. Veracity. Truthfulness. You know, it used to be when I was in college, you did the research and you came to the answer. Now you do the research, you come to multiple answers, you need to decide which one is the most valuable, which is the right one, what data can be considered trustworthy. And then finally, the most important one in my view is value. I mean, it's all about converting the data into knowledge. Now, it doesn't necessarily have to be in dollars, euros, ringgit, or baht. I mean, there could be another type of value derived. But again, it's all about translating into value. So those are the 5 V's that are traditionally thought about. There are 2 additional V's that I think are extremely important. The first V is variation. So what's the difference between variety and variation? So this morning at the hotel, I went into the restaurant, and there was probably 7 or 8 different types of muffins that were out there that I could choose from. So that's variety. Now, I ate one of the muffins this morning. It was excellent, crunchy, full of fruit. Now I ate the same one tomorrow. Maybe there's less fruit, it's soft. The following day, not as much fruit. That's variation. Now, why is variation important? A big part of big data these days is social media, bringing in social media and analyzing it. And if I asked you a question, what do you think of my presentation? And you say, it's good. That's a very powerful statement. But if I ask you and you say, it's good, that isn't as powerful and perhaps might be conceived as a negative statement. Yet, it's the same wording. That's an example of variation and the need to be able to tell the difference between the same content appearing but meaning two very different things. And the seventh V, is visualization. I had the opportunity a couple weeks ago to visit San Francisco, Silicon Valley. And I spoke with venture capital firms about big data. Now, big data is still a huge issue with venture capital firms. Last year, they invested $6.6 billion in big data tools, and we'll talk about some of the big data tools later. And the area that is the hottest is visualization tools, because they recognize that the big data serves no purpose unless it can be presented and depicted in a way that makes sense. In fact, you're all familiar with the term infographics. That term didn't exist 5 years ago. I think it was coined solely as a way to demonstrate and show the value of big data, because it tells a story through pictures. Now, I recognize that most of you are academics, you write papers, and that's a valuable way to show big data. But in my opinion, the more valuable way is through these charts, tables, pictograms as a way to illustrate big data. So when I think about big data, I think of those seven V's. Now, who's interested in big data? Again, the simple answer is everyone's interested in big data. But I want to talk about some large international organizations and large countries that have big data strategies or big data initiatives. So in the lower left-hand corner, we see the cover from a 2014 report put out by the World Economic Forum. The World Economic Forum each year, a bunch of smart people meet in Davos, Switzerland, and discuss important issues. Each year they put out this, the Global Information Technology Report that talks about a country's readiness, ICT readiness, technology readiness, ICT, information communications and technology. But at the front of each report, each year they deal with an important topic. In 2014, they dealt with big data, and they talked about the risks and rewards. The bottom line was they talked about the great value that big data could bring, could change the world, but the threats associated with that and how big data had to be looked at, analyzed, and dealt with cautiously. The same holds true for this report, which was put out by the UN Global Pulse, which is part of the UN General Secretariat. Now, it looked at big data in the context of the developing world and crises and how it served the undervalued populations, underreported populations. And they called it challenges and opportunities. So you see the theme, risks, rewards, challenges, opportunities. Both recognize the true value that big data can bring to decision-making, to actions, but also made clear, clarion clear, that that there's certain risks and certain risk mitigation efforts that need to be undertaken. So let's talk about some countries with big data strategies. China. China currently doesn't have a big data initiative, but in March of this year, at the 13th Party Congress, they announced their 2017 to 2021 5-year plan. And in that, they said that they were putting out a big data strategy. And it was going to focus on something called social governance innovation. I don't know exactly what that means, but when I had the opportunity in the aftermath to look through some of the reports and some of the Xinhua reporting on what this meant, they made clear that the idea was by 2017, the Chinese government would be on a standard data platform. And furthermore, by 2018, they would start releasing key economic, financial, housing data to the public, putting it on the platform. Which is very interesting because in 2015, President Barack Obama, for the first time, appointed a chief data officer for the United States. And that chief data officer, his primary goal was to take government data and make it publicly available. So there are currently 130,000 data sets, and I'm sure many of you have used them, on a site called data.gov. And it's growing all the time. So that's the case of China. In the case of India, India has a big data initiative. It is run out of their science and technology department. And it's a large amount of money was set aside for big data projects. So universities that were doing research in centers of excellence for big data, or topics like machine learning, natural language processing, could all tap into these funds. The UK, which you see here in the center, has a big data initiative. And they even title it the Big Data Dilemma, because again, it deals with risks and rewards. Their initiative involves three parts. The first part is human capital. Absolutely essential is getting people with the right skills and training to handle big data. And we'll talk about how important that is later. Second has to do with giving people the right tools. You could have all the great data out there, but if you don't have the tools to translate it into knowledge, it's useless. And then third is the issue of collaboration, talking across the government. Australia has a similar program, a big data initiative, where they've put out a document which is guidance for the government on how to use big data and how to safeguard big data. Safeguarding big data is a huge issue because releasing sensitive government information and what we call PII, personally identifiable information, is a great concern. And so a number of efforts have been made to safeguard that. And it's codified in the Australian Big Data Initiative. So those are a few of the programs. So what's occurring with big data initiatives in the United States? So in March of 2012, Barack Obama signed the Big Data Research and Development Initiative. And in his comments when he signed this, he called this an all hands on deck. What did he mean by that? Well, he said that this can't be handled or addressed just by the government alone. We need corporations. We need research institutions. We need public policy advocacy groups like Big Data Without Borders. We need all these groups working together to help solve this big data issue. And so $200 million was set aside in new commitments to 6 different federal agencies. And some were in defense for developing autonomous systems. There were some in health for making publicly available genome data. The National Science Foundation was given money to help build the next generation in the U.S. of data scientists and data engineers. And we see consistently with the government big data initiatives that they recognize that there's some fundamental framework, a groundwork that needs to be established and created. We need to have the skills, people need the skill sets, and then people need the tools, and then you can begin to get results. But if you don't have the skills and the training to look at big data, and we'll talk about some of the big data jobs later, it falls flat. And so this council, or this initiative, has been working for the past 4 years. And it's just recently, this past year in May, that they came up with they put out their strategy. And this strategy document is publicly available. And it's built around 7 key strategies. I'm not going to go into each of the strategies, but I will say that trustworthiness, that is evaluating the data and determining its veracity, is one of the pillars. And another pillar is the importance of sharing and collaborating. Another one is creating the right security infrastructure, the cyber structure, for handling big data. And a fourth is creating the infrastructure for growth in this area. That is, funding universities and organizations to develop big data departments, big data programs, big data tools that will help with understanding and better using big data. So that's quickly the state of big data in the United States. Let me now turn to what I consider to be a few interesting case studies and uses of big data. And as was mentioned earlier, and I've heard mentioned this morning throughout some presentations, you can find examples of big data everywhere. The three I'm going to talk today are about healthcare, security, that is national defense, and I'm going to talk about big data and crowdsourcing. So the first example I'd like to talk about is the Zika virus. Now, it was previously mentioned that big data, we heard about the Google effort looking at the flu epidemic. Well, big data has been previously used to address health crises, the Ebola crisis, SARS, the avian flu virus. Big data played a role in all of those. And the Zika virus has been in the news because of the recent Olympics. It is a prominent problem in Central and South America, and many people were worried about contracting that virus at the Olympics. Now, there's no known cure for the virus, but in most people, if you get bit, and it's transmitted via the bite of a mosquito, you get bit by a mosquito, you'll have some local rash or something very mild. However, the problem is, if you're female and pregnant or looking to get pregnant, it has been shown to lead to birth defects. So obviously this is a very important concern. So how does big data play a role here? So we know it is transmitted via a specific mosquito. We know where the mosquito's breeding grounds are. They like warm temperature, they like warm, humid, and they need standing water. The eggs are laid in water. And so, big data, you probably can't think of a bigger data set than climate data. And so climate data was analyzed, rainfall, temperature, and humidity, to determine where hotspots likely were for the outbreak of Zika. And then they took human travel pattern data, looking at how people from those regions moved. Now, for example, if there was an outbreak in the deepest parts of the Amazon forest, that population doesn't move much, it's not a problem. But if it's co-located with an urban area where there is great transit, both nationally and internationally, then it's a concern. So they use that to track where the Zika virus is and where it's gone and where it's likely to go. And then interestingly, there was the use of cell phones. This first occurred during the Ebola virus. What was done was cell phone providers handed over anonymous data, phone data and text data. And it was mined to look at, for example, people sending emails to calling their friends and saying, I don't feel so well, I'm going to the local clinic, or other information that could be used to determine where it might be spreading. So it's this combination of these three things, the climate analysis, human travel patterns, and sifting through cell phone data. And cell phone data is extremely valuable because in many parts, for example, in the Ebola virus, there's many parts of Africa where there aren't landlines, but there's very few parts where there aren't cell phones. So finding that cell phone data and using that cell phone data was extremely valuable in helping understand the Zika virus. And again, there's no known cure. Simply putting on spray, wearing longer shirts, not being out when the virus breeds all help. And so by understanding where it is and where it was going, big data has helped with the Zika virus. So this ship on the right doesn't look very impressive. It's about 130 feet long, about 40 meters. It can travel 10,000 nautical miles at a rate of about 12 knots per hour. Now, if you know anything about ships, this isn't going to impress you. But note that there are 3 people, well, you probably can't see from there, there's 3 people standing on the deck of that ship. They're not needed. This ship moves and acts on its own. And it can cover that distance. There's no need for humans on it, and very little human interaction. Now you might say, well, that's just bringing what we know in the sky, the use of drones, to the water. But there are some significant differences. The first, as it's explained, is spare remote supervisory control. What that means is there's not somebody in a little cube steering the ship and moving it around. They're maybe every several hours checking instruments or looking at various data to make sure everything's online and working. But this is operating on its own. The second is there's a theory about airplanes called big sky, small bullet. And what that means is there's not a lot of worry about planes crashing into each other. There's not a lot of worry about, you can basically navigate in the sky straight and not have to worry about moving about because of other planes or other objects in space. However, when you're on the water, there are some very specific maritime laws which govern how ships interact. And so when this ship was being built, into the technology had to be factored in these called COLREGs, these maritime regulations. And in addition, you can imagine, as you see, the submarine is used for, it's not just used for transport, but it's used for tracking diesel-powered submarines and countermine activities. So you could imagine one use would be this ship would go into a harbor ahead of other ships, determine where mines are. And of course, in a harbor, there's likely to be other ships. So you can begin to appreciate the data and the sophistication of information needed to run a ship autonomously. And then, of course, there's the cost. A U.S. destroyer costs $700,000 a day to run. This ship costs about $15,000 a day to run. So there's a huge cost savings. I'd like to talk for a second about crowdsourcing and big data. So if you look at your phone, they say that there is more computing power in this phone than all the power that NASA, the U.S. National Aeronautics Space Administration, used in 1969 to send someone to the moon. And inside your phone, there are numerous sensors. And what I'd like to talk about is something called sensor repurposing. So for example, in your phone, most phones now have barometers in the phone. Now, what does a barometer do? Well, a barometer helps determine altitude. And by doing that, it helps with GPS. As you know from all these apps, you'll see GPS, do you allow us to know where you are and such. So there's a very good use for a barometer in our phones. But that sensor can be repurposed. Because most people, if you listen to the weather forecast, they'll talk about barometric pressure. Barometric pressure is an excellent indicator of weather, current weather and future weather. And so there are, for example, apps out there that do this sensor repurposing or sensor splitting that allows it to serve that purpose. There's a weather app where basically every phone can be turned into a mobile weather station, and they're collecting data consistently. So what is the value of this? Well, if you're traveling in London, instead of knowing what the weather is going to be at in the afternoon in London, you could know that the weather in Hyde Park from 3:45 to 4 o'clock is going to be raining. Because people walking through that are constantly providing this barometric information that allows a weather organization to analyze it and provide hyper-local weather forecasts. So I predict in the future you're going to begin to see these hyper-local weather forecasts as you travel locally and internationally. We know that phones are already used for traffic, because the way the phones work, you communicate is via the cell towers. And so if there's 3 cell towers, you can triangulate where you are with your phone. And if there's a grid overlaid on that and they know you're on a highway, your movement from one tower to another, they can tell how quick you're moving. And if you're on a highway and you're only moving at 10 kilometers an hour, they might not know what the problem is, but they'll know there's traffic. So there's a number of applications out there that use this crowdsourcing, that use this cell phone data to help improve understanding of traffic and help you better get from point A to point B. In fact, some of them, as you know, can reroute you real time and help you get from point A to point B. Earthquakes. There is in your phone something called an accelerometer. An accelerometer helps you understand in 3 dimensions where you are. So an accelerometer is used, for example, when you turn your phone. It changes from landscape to portrait. Well, how does it know? It's using the accelerometer and recognizing that you're changing in 3 dimensions. But that same accelerometer can be repurposed to help determine earthquakes. It is said that there's thousands of earthquakes that occur every day around the globe. And while knowing an earthquake occurred is not an indicator of future earthquakes, the belief is that the better we understand earthquakes, the better that we'll be able to predict them in the future. And so people's phones, you can turn them into basically seismic indicators. And this day, Caltech, California Technology Institute, has a program in place where they collect that data and very accurately map out these type of earthquakes around the globe. Public appeal, crowdsourcing, is also very popular. You're all familiar with the disappearance of flight MH370 a number of years ago as it was flying from Kuala Lumpur to Beijing. Well, they couldn't recover the black box, and they recognized that over where it could have crashed was over 24,000 square miles of water. Just too tough to analyze. But what happened was Digital Globe, which is an organization, a satellite imagery organization, made public all the pictures of all 24,000 square miles and opened it to the public. In essence, asking the public for the help in helping solve this problem. And some of the leads came from individuals who looked at the data. Now, again, you have the problem of amateurs looking at it. We have the problem, we discussed the trustworthiness. But nonetheless, here's an application of big data for the public good. The same was true with the Boston Marathon bombing of several years ago. There were about 100,000 people lining the streets to watch the Boston Marathon. A bomb went off. Within an hour, the U.S. government made the plea for people who had taken pictures or video during that time to send it into the FBI. 120 FBI analysts sorted through 13,000 videos and 120,000 pictures. And some of that helped lead to capture and help build the case against the bomber. So again, these are examples of crowdsourcing and use of big data. And again, it helps with accuracy and timeliness. If you cannot process the data, perhaps crowdsourcing is a way to help. So I'd like to now turn to what are the key challenges that organizations face in addressing the big data, the issues of big data. And there was a study done that said 55%, over half of the projects of big data are not completed. They fail. Well, why is that? In some of the discussions this morning, we heard a bit about what the challenges are. But here are the 5 that I think, from my experience of heading KM organizations and doing consulting for the past few years, these are the 5 that I think are the key issues. The first is, confusion caused by big data. Most organizations believe that I'll just capture everything out there and then we'll figure it out. We'll analyze it. And as you know from your phone, the more applications you put on, the slower it gets. The more you fill up your hard drive, the slower it gets. Downloading a Microsoft Word document is a lot different than downloading a full-length video. It's slow, it's tedious, it's cumbersome. Well, the same holds true if you capture all this data. Trying to process too much data causes problems. And when I use the term bad data here, I'm not saying wrong data. What I'm saying is it's just white noise, not valuable information, not valuable data. So a key is for an organization, they need data discipline. You need to create a strategy, a collection strategy. You can't say, well, we'll gather everything out there, we'll analyze it, and we'll get to our answer. You need to look at the data, constantly revisit it, determine what the good data is, what you need to capture. In America, we have a term GIGO, garbage in and garbage out. If you're collecting all garbage, your results are going to be garbage. And when I meet with clients, one of the first questions I ask them is, what is your collection strategy? Because I tell them, if you want me to put in place a knowledge management system, all I'm allowing you to do is make a bad decision quicker. You need to have the right data coming in. So I spend a lot of time when thinking about knowledge management systems and the data coming in. The analogy I use is the food we eat. If I went each day to McDonald's, I'm not going to be performing at my peak. But if a balanced diet, eating better food, putting the right food in the system allows my system to process it, turn it into valuable energy, and allow me to perform. So too is the same with systems and organizations. They need to be fed the right data. Now, I'm sure I don't need to tell many of you, but the bottom line is the software and the tools out there, they're not easy to manage. If you think Hadoop has been around for 10 years now. Hadoop is the open framework that stores and processes big data sets. It's very popular because it's open source. But look at this quote on the right. And this is from a gentleman who should know some things. The chief cloud architect at Yahoo says, let's face it, this is not easy to use. I mean, the tools out there are not easy to use. Although I will say that there's two factors taking place that's going to help with this. One is competition. So for a decade, Hadoop was the main player. Over the past couple of years, I would say that Apache Spark has grown. Apache Spark is faster, easier to use. So as competition grows, as the market matures, the tools out there are going to mature, and it's going to be easier to use. In addition, big data is still, as we heard, big data is still relatively new. In organizations, there's maybe a few people working on big data. Well, who do they turn to? They don't really have a user group or communities to turn to that are mature. Yet over time, as more people enter the field, the understanding gets greater, the ability to use the tool, the learning curve flattens out. So I think that one of the challenges, they're not easy to use now and probably still will be difficult for the next several years. But as the big data area gets more and more developed, you're going to see that the systems are going to become easier and easier to use. Now that being said, with all the systems out there, new ones introduced all the time, the learning curve keeps going. It goes up and then it flattens and it goes up. So it could be seen as a continuous cycle, but I think that over time they'll become easier to use. So what happens is, because the technology is hard to use, you focus on getting the technology right rather than the problem solving. So too much time is spent. So we talked about 55% of projects fail. Well, of those 55%, 3/4 fail because of the big data platform and the difficulties with it. Now, an organization has to be developed enough to handle big data. So what you see behind me is the 5 phases of big data. So the first is high-level understanding, introduction of big data into your organization. The second is sense-making. This is where you actually say, okay, I understand big data. Here's how it works in my organization. The third is you begin to introduce pilots into your organization. You know, get people excited, get some wins, get some wind under your sails, get some wins in the organization. The fourth then is understanding the value. That is going beyond one pilot and doing multiple pilots to show that the organization as a whole benefits from big data. And then finally, integration, where big data becomes part of the DNA of big data analytics, become part of the DNA of your organization. Now, I can't tell you phase 1 is 6 months, phase 2 is 3 months, and give you a timeline. That largely depends on the organization and communication within. And for every every big data challenge, you need to have a communications and change management plan in place. It's absolutely essential because big data is new, and anything that's introduced as new inherently worries people. And so you need to communicate what big data is. All throughout this, you need a communications plan and you need a change management plan in place. So we talked earlier about the number of formats that were out there for big data. Now just imagine you're a company, you're collecting big data. You're getting big data from individuals, different countries, different languages, different formats, different syntax. And when I say different syntax, let's use, for example, you're an organization that looks at nuclear, atomic and renewable energy. Well, somebody writing in a blog is going to use a much different syntax than someone writing in a peer-reviewed journal. Now, the value could be high of each. Again, it's the trustworthiness issue. But they're written stylistically much different. In one case, somebody might have 140 characters to get their whole point across. So it's written much differently, but could be conveying the same thing. So how do you synchronize? How do you compare and use this data? If one person uses a definition for a reactor that's different than another person, well, you need to somehow come up with a commonality of definitions, metadata creation so that you're using the same language, you're using the same terms. ETL, extraction, transformation, and loading of data. Well, how do you do that with unstructured data? These are all challenges that organizations face. And to do that, you need governance in place. Now, I've headed data governance and had responsibility for data hygiene for a number of organizations. And I can tell you that it was infinitely easier with conventional data. Just simply with big data, the cybersecurity infrastructure, the protection of information, sensitive information, puts it on a whole order of magnitude different than with conventional data. And what happens is, if you're getting data at different levels and it's not synchronized, you get bad results. And bad results invalidate the whole reason why you're collecting big data to start with. So one of the key features of data is that it can enter an organization at many points in many different formats. Couple this with the fact that most organizations are siloed, and big data equals big problems. So take, for example, this org chart. You look at maybe some data comes into strategy, engineering, the finance, or the R&D department, and they do, there's not a central repository. So they're taking what they think is big data, and it could be terabytes, petabytes, exabytes of data coming in. But they don't have the complete picture because the other departments are collecting information as well. So the problem you have here, structured, unstructured data coming in, and people performing the analysis or insights without the complete picture. Now you could always say, well, collect more information, get a more complete picture. That's true, but in this case, I'm referring to just within your organization, because that information has already been vetted and such. So you have the problem organizations don't talk to each other. Now this is extremely prevalent in the U.S. government, and that's why we heard about the U.S. government, the UK government, all putting emphasis on sharing and collaboration, because the data, they recognize that you're wasting time if you're making data decisions with incomplete data. The other problem you run into is you could do analysis on a particular data set, and the other group could have done the same thing. So there's a problem of duplication of effort. So with big data, there's the true challenge of interoperability and discussions across all the various departments in an organization. So when your organization thinks about big data, you have to, hand in glove, think about change management and making sure that data is flowing frictionlessly, seamlessly across your organization. So to finish up, now that we've talked about the challenges, there are, I believe, 5 rules, 5 activities that we as organizations can engage in to help us extract big knowledge from big data. And these are the 5. So let me start with the first. You need to constantly monitor the technology landscape for changes. Sources, we talked about, you constantly have to look at sources, vet sources, determine which are valuable. Some appear, some disappear, some combine. So what sources are you using coming in? You know, there's a new source out there. Is that valuable? Is that worthwhile? New tools, we talked about how new tools are coming in all the time, and they need to be understood and recognized. Computational capabilities. We were by 2018 supposed to be able to conduct exascale computing. That's 1 billion calculations per second. That's been pushed out for some years, but nonetheless, computational capabilities are greatly improving. And then modeling techniques, looking at all these data sets. How do you model the data? So the bottom line is an organization needs to dedicate resources to monitor and respond to the changing environment. Now, when I say respond, that doesn't mean every bright new shiny toy. You know, you talk to IT about purchasing. But what it means is to look at your big data strategy, determine how this new tool or this new change in how work is done fits in, and determine whether or not you need to revise the strategy. So here's a chart which you will not be able to read, but this is the big data landscape, and this just gives you a sense of all. Gives you a sense of all the tools that are out there, and it's constantly changing. You know, infrastructure, analytics, and applications, the 3 areas. And then, you know, you can look at in infrastructure. We talked about Hadoop, Spark, new SQL databases, no SQL databases. You can look over at the analytics, statistical computing, some of the applications in certain areas, open source, cross-infrastructure and analytics. Just a huge amount of tools. It's impossible to process, but you need to, at least in the broadest sense, read, you know, Gartner, look at the Magic Quadrant, keep abreast of what the tools and the developments are, because it's a constantly changing framework. Okay, so organizations traditionally are built hierarchically. That is, it's a pyramid and decisions are made at the top. You know, decisions are made at the top because the belief is this person has seen it all, done it all, they've had experience, they're more qualified. So, and that, you know, collection, analysis, and then as you get further and further up, the big decisions are made. So that's traditionally the big decision making. So it was done by the experience. But what you see is we've moved from here to here. Now decisions should be data driven. It's the person who's looking at the data that needs to make the decision. This serves a number of purposes. One, it makes decisions quicker because the person looking at the data can make the decisions. It doesn't need to go through all the layers. It requires a change in your organization to trust the data and trust the people looking at the data. And I'm not here to say that that's an easy challenge, but one of the things what big data does is it promotes data democracy. Decisions made, contributions from all, decision making is distributed throughout the organization. And so you need to trust the data. Experience is great, the understanding, but with big data, we're talking about data-driven decision making. So solving big data requires big data skills. Think about some of the jobs listed today. They didn't exist several years ago. I don't ever remember seeing a social sentiment analyst job position. I don't remember seeing data engineering. And what's interesting about these new positions, well, first, it's very difficult for people with traditional skill sets to translate into this because it's so different. In addition, the skill sets are a collection of different skills. So data scientists need communications analysis, visualization, all sorts of different skills and different tools. So what you're looking at is a new breed of employees with a skill set. And so you need to find people with the right skill sets. And you need to think differently. And what do I mean by this? Perhaps the best example was in 2004 when Google went public. In their IPO letter, initial public offering letter, Sergey Brin and Larry Page said that Google employees spend 20% of their time thinking about other things. 20% of their time not on their core work. And this has worked wonderfully for Google. AdSense, Gmail, Google Maps, all came out of this idea of spending 20% of your time. Now that's, Google has a certain culture that is amenable to that. But the bottom line is, you need to think differently. Because big data, what big data does is it allows you to find answers from unconventional data sets that previously you could not have. So you need to ask the right questions. So for example, when I was on the plane ride over, I do a lot of traveling, so I catch up on my reading. And I was reading Sports Illustrated, which is a U.S. sports magazine. And one of the articles was titled The Metric System. And it said, new technology has produced massive piles of data about everything that happens on a baseball diamond. All kinds of answers are in there. Finding an edge is all about asking the right questions. And that's really what we're talking about, asking the right questions. For several years, it wasn't mentioned during my bio, but I was in the military for 8 years. During that time, I headed the U.S. Army's long-range strategic planning. I did ran all the war games for the U.S. Army. And one set of people that I always made sure to attend the war game was science fiction writers. Because they thought out there. They didn't think outside the box. They were redefining the box. And you need that type of thinking. And I think that's why the skill set that we had on the previous slide has so many pieces. Because you need someone who has experience across a number of areas and can ask the right questions, put the pieces together correctly. And so organizations are struggling with, how do we think differently? How do we answer questions that previously we couldn't answer? How do we know what sales are going to be like next Thursday? For example, Walmart, huge U.S. corporation, gets daily sales reports. They can tell you point of sales in a store, in a state, at the end of the day. I mean, how do you use data like that? What can you use that data for to help drive future decision making? Some obvious, some less so. And And then finally, the bottom line is, although we're making great progress in artificial intelligence and machine learning, the bottom line is the last bit of work, the last mile, the last kilometer needs to be done by humans. And so organizations need to optimize their human resources. They need to recruit across the talent set that we talked about. And they need to retain those people. Richard Branson, the only individual in history who has created $7 billion companies, 7 separate billion-dollar companies, likes to say, I like to give the people the skill set to do well, but make it exciting enough that they don't leave. And that's truly the worry with HR. You talk to any HR person, and they'll tell you, well, what if we train this person, they're going to be too valuable, they're going to go work for somebody else. Well, the trick is to make it exciting. Maximize the training, the educational opportunities, maybe the rotational opportunities within an organization. And create an experimental environment. I've probably hired 100 or 200 people in my career. And I tend to like people who have been with organizations for a long period of time. Maybe not people who've only been with one organization, because then transition's difficult, but it shows continuity and stability. Yet if you go out to California and in Silicon Valley and look at people's job resumes, you see every 6 months they're finding a new job, new job, new job. And I've come to learn the value of that, because how do we learn? We don't learn from our successes, we learn from our failures. And creating a fast-fail environment, that is one in which you try things, it fails, you say, oh well, we tried it, you move on to the next, I think is the wave of the future for organizations. They need to have this experimental environment, especially with big data, when we're just now understanding what the boundaries of big data are. You need to try things, you need to experiment, and the organization needs to know that if you fail, not too often, but if you fail, you move on. And so it's this way we create this environment that makes people excited to be there and really is an additional way of investing in people. So in conclusion, these are, again, the 5 areas. Increase vigilance. Make sure you understand how the market, big data market, is evolving. Promote data democracy. Data-driven organization. Push data decision-making down to the lowest level. Find the right skills. Get the people with the right skill set. As an organization, think differently, because you're dealing with different data here. You need to think differently. And finally, it's all about the people. Invest time and invest resources in the people. Thank you, and I'm happy to answer any questions.
Thank you, Mr. Lee. So I now open the session for the floor. Any questions from the floor? Yes, please.
Hello. I wonder that how large is a data set that you consider as a big data in terms of terabyte or in terms of how many samples it is?
What constitutes big data is what your question is?
How large of a data set? If I was working on like a 1,000 of sample and try to analyze something, I can say that I'm working on a big data or not.
Well, I mean, that's an extremely difficult question to answer.
It's very difficult.
Yeah, I mean, to a large extent, big data is locally defined. If I'm a small, as I go back to that definition of big data is a buzzword, and it refers to data that is so big it stresses your system. I mean, I think that's one way to, if you're a small company and you're working with terabytes of data, that might be considered big data. But I know there's a colleague in the room from IBM. What is Watson process? What constitutes big data? They might be talking about multiple exabytes of data. So I mean, the bottom line is big data, I think, is going to be locally defined by the organization. It really refers to data which previously you haven't been able to process. Now, if you were processing terabytes of data, then it's petabytes of data. If you were working with exabytes and zettabytes and yottabytes of data, then it's the next order of magnitude. So I know that that's not a very good answer, but the bottom line is big data to a large extent needs to be locally defined by you, and it refers to data that basically large data that stresses your system that you haven't been able to process in the past and are now able to at least begin to think about how to process.
Okay, thank you.
Other questions?
Assalamualaikum warahmatullahi wabarakatuh. My name is Ardian. I'm from Sultan Agung Islamic University, Semarang, Indonesia. I want to ask you, you said that there is a bad data and good data around us. Unfortunately, we have a lot of data in here. I think it's difficult to analyze it because we have lost data. And can you give us how we can spare it between bad data and good data?
So, at the slide I had up, it was talking about data discipline. And it really comes down to understanding what questions you are trying to solve for. So what are you trying to get to? And from that, you begin to then work backwards. So the best way I think about data discipline is thinking about what am I trying to answer? Because if there's large data sets out there and I'm looking to solve question A, I need to then go back and say, well, what type of data do I think would support my information in that space? And if you find out that you're still pulling a great deal of data, let's use the Zika virus. Let's say I'm trying to understand the Zika virus. I'm trying to understand where likely outbreaks are. So you look at that and you say, okay, I need climatic data. Okay, and then what elements of climatic data do I need? And then keep asking the question, is this, and then constantly running the data against those questions. Is this exactly the data I need? You don't pull down again, you're only looking at climatic data for temperature, rainfall, humidity. I mean, there's a number of other climatic elements out there. You rule those out, so those data sets are out. Then you look at, well, maybe I don't need this data set, so you keep eliminating it down to make sure that you're focusing on exactly the data that you need. But it all starts with, what are you trying to answer? There's the idea of boiling, you can boil the ocean, bring all the data in, and hopefully it'll distill down to what you need. But what you're really looking at is, what's the answer I'm looking to achieve? And then thinking logically about what data needs to come in, and constantly looking at that data that's coming in to determine if that's the right data. Now, the more important question is, how do you know when you get to the right data? And I think that's what you're getting at. And that's a difficult question. That begins to, to a large extent, there's some tools out there to help with that. But that's still a frontier that hasn't been explored yet. How do you know, what are the rules for what's good data? And I mean, right now it's sort of you individually, you as an organization have rules-based approaches. But over time it's going to be, via machine learning, you'll be able to eliminate what the sources are and really get it down to the core data. But I think one of the biggest and most exciting areas in big data is kind of getting down to determining what the right data is. but you can begin by the human element of looking at what you want to answer and working back and seeing if that data supports that information. Other questions?
Other questions from the floor?
Thank you. I'm Sutaga from University Technology Malaysia. Well, you talked to us about big data in healthcare, in security, and many other areas. Now, what about education? From what I see, especially in higher education, there seems to be a lot of clutter and noise out there. You have various new pedagogical applications, for example, MOOCs and wikis and open learning resources and various other applications. So do you see that there's like a proper strategic management of all these resources at regional levels, or is this another frontier that needs to be tapped?
Well, it is a frontier that needs to be tapped. I mean, one of the interesting things that we see in the United States is this is the first time in history that 4 generations of workers are working together. You know, you have the baby boomers, Gen X, Gen Y, and the millennials. And the problem is each of them learns differently, you know, and how they consume data. So as you said, you know, for a younger generation, what I found is most useful is, you know, kind of the gamification of education. But that doesn't necessarily hold true for, I call it more established, older workers. And so what I think you're seeing from an education standpoint in and I'm talking about corporations now, about how they train people, is what you're finding is a very flexible, multi-dimensional way in which they teach. And people are given the opportunity to, in one organization, which I'm familiar with, you're given 4 or 5 different ways to learn based off who you are, and it's not predetermined. You're told you need to understand this particular module, and this particular module could be paper-based, it could be online group, it could be asynchronous learning, it could be a host of different ways. So I don't think that in education, as you said, there's multiple pedagogical models out there, but I think that the reason there's multiple pedagogical models out there is a reflection of the people in the education space. And as people are learning, you know, during times of layoffs, people get re-educated. So there's a huge age range, not just in traditional classrooms, but in organizations as well from learning. And so I think what you're seeing is, I used the term with Weather earlier, kind of hyper-local education. I think that's what you're going to see. There's going to be multiple models, and there's not going to be able to be a single model just because of the nature of people, how they learn, how they absorb. And so I think it is an interesting frontier, and I think it's one that's ripe for analysis. But as it stands now, I think that it's you know, bifurcated, and there's going to be different models for different people at different levels.
In other words, you can't have a single blueprint that serves everyone.
That's right. You know, so it's interesting, when I worked in the military, one time, I was in military intelligence, but one time I went down to the motor pool to look at, you know, how, you know, I went to go see what they were doing, and I looked at the manuals how they fixed the trucks, and it was written like a cartoon. It was a cartoon character. Sergeant Snuffy was doing this and this, because that's how, you know, the people, that age group, which was roughly in the motor pool, probably 17 to 21, you know, they were used to reading comics and such, and so that's how they learned. I mean, that's not how the generals would learn, but that's how they learned. And so I think, I think, you know, one thing you can't do, people are hardwired for how they best learn. I think over time you might be able to change, but in general, people are hardwired for how they think. Some are more visual. You know, it's interesting. My wife and I, you know, during discussions, so she'll give me with directions. She'll say, "Oh, turn left here, turn right there, and yeah, here's how you go there." And I say, "That doesn't work for me. Give me landmarks." Well, turn left at the church, turn right at the supermarket. That's how you get there, because that's how I perceive things and think about things. And I think that holds true for individuals, how they think and how they perceive things.
All right. I'm sorry to interject, but I guess this is all the time that we have for the first keynote session. We'll proceed to the next session. Okay, so thank you, Mrs. Scotty.
Sure,
for the
thank you.
wonderful.
And I will just say I will be here through the entire 2 days, so I saw there were a few additional hands. I'm more than happy to chat during lunch and during the break. Thank you.
Thank you, Scott.